Good afternoon all. This is Satish Kumar, Assistant Professor of VC Department. Now let us see the another video lecture series on block diagram representation in LTI, discrete time systems. The discrete time systems are represented by block diagrams. They are also called structures of discrete time systems. It can be classified into four types: direct form 1, direct form 2, cascade form and parallel form. Now we can see the basic elementary blocks of signal: adder x1 of n added with x2 of n, which can produce output as x1 of n plus x2 of n. Constant multiplier x of n added with constant value, we can get it as your a into x of n. Unit delay element means x of n multiplied with z inverse, we can get x of n minus 1. Signal multiplier x of 1 of n multiplied with x2 of n, y of n is equal to x1 of n into x2 of n. X of n multiplied with z bar plus 1, therefore y of n is equal to x of n plus 1, advancing element. Multiplication x1 of n multiplied with x2 of n produce output as y of n is equal to x1 of n into x2 of n. Therefore, y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. X of n multiplied with 0.5, we can get 0.5 into x of n. That can be added with y x of n minus 1 means x of n, where we can get the delay element which can produce output as x of n minus 1. Y of n multiplied with z inverse, we can get it as your z inverse into y of n, we can get y of n minus 1. That can be both multiplied and added with 0.5 into x of n. This is the h of z is equal to 1 divided by 1 minus a z inverse x of n. We can get it as your output as your y of n. That can be multiplied with z inverse, again multiplied with a. Therefore, we can get y of n minus 1 into a. Therefore, a into z inverse into y of z. We can get the output as y of n. Again, y of n multiplied with a into z inverse, which can produce the output as x of n. H of z is equal to y of z divided by x of z. Therefore, y of n is equal to a1 into y of n minus 1 plus a2 into y of n minus 2 plus b naught of x of n. B naught added with x of n, which can produce as output as y of n. Y of n minus 1 means a1 multiply y of n multiplied with z inverse, we can get y of n minus 1. That can be multiplied with a1, which can produce a1 into y of n minus 1. Again plus a2, y z inverse y of n minus 2. That can be multiplied with a2, which can produce the output as y of n. Therefore, a1 into y of n minus 1 plus a2 into y of n minus 2 plus b naught of x of n. This is the basic general direct form 1 flow diagram, which can be given h1 of z, h2 of z, finally h of z multiplied with h1 of z into h2 of z. Next, h of z is equal to direct form 2 means we can take the simple method is y of z divided by x of z is equal to y of z divided by w of z into w of z divided by x of z. Next, this is the basic direct form 2 structure, which can be given. We can take z inverse as common in the direct form 2. Now we can see the structure. Y of n is equal to 3 by 4 into y of n minus 1 minus 1 by 8 into y of n minus 2 plus x of n plus 1 by 2 into x of n minus 1. X of n multiplied with 1, right? We can get added with 1 by x of n minus 1 means x of n have a delay element z inverse, multiplied with 1 by 2, we can get it as a 1 by 2 into x of n minus 1. So similarly for y of n added with 1, therefore we can get it as your z inverse into again multiplied with 3 by 4, therefore 3 by 4 into y of n minus 1. That can be added with again z inverse means multiplied y of n multiplied with z inverse, again multiplied with z inverse y of n minus 2. That can be multiplied with minus 1 by 8, we can get it as your 3 by 4 into y of n minus 1 minus 1 by 8 into y of n minus 2 plus x of n plus 1 by 2 into x of n minus 1. Similarly, for direct form 2, y of n is equal to 3 by 4 into y of n minus 1 minus 1 by 8 into y of n minus 2 plus x of n plus 1 by 2 into x of n minus 1. Therefore, we can the method we can be used is, therefore y of z divided by x of z is equal to y of z divided by w of z into w of z divided by x of z. Is it clear? Therefore, y of n term can be changed, x of n can be changed. Therefore, y of n is equal to multiplied with 1. Y of n minus 1 means we can take z inverse. Z inverse into multiplied with 1 by 2, we can get it as your y of n. X of n means added with 1. Again, z inverse means x of n minus 1, that can be multiplied with 3 by 4. We can get it as your 3 by 4 into x of n minus 1 added with. Next multiplication term. Z inverse x of n minus 2 multiplied with 1 by 8. We can get it as your, therefore we can get it as your x of n plus 3 by 4 into x of n minus 1 minus 1 by 8 into x of n minus 2 plus y of n plus 1 by 2 into y of n minus 1. This is the direct form 2 structure. Next, consider as direct form 1 and 2. H of z is equal to 1 plus 2 z inverse plus z square, 1 minus 0.75 z inverse plus 0.125 into z power minus 2. H of z is equal to y of z divided by x of z. Therefore, multiplied with h of z multiplied with y of z. Therefore, we can converting into a difference equation, x of n plus 2 into x of n minus 1 plus x of n minus 2. We can get it as your y of n minus 0.75 into y of n minus 1 plus 0.125 into y of n minus 2. Now we can take y of n as common. Therefore, x of n plus 2 into x of n minus 1 plus x of n minus 2 plus 0.75 into y of n minus 1 minus 0.125 into y of n minus 2. Now, for this structure, we can going to realize the direct form 1 structure. X of n added, we can multiply, we can produce the output as y of z, y of n. That can be x of n minus 1 means we can multiply it with z inverse into x of n minus 1. Again multiplied with 2, we can get it as a 2 into x of n minus 1. Therefore, z inverse into x of n minus 2. Multiplied with 1, we can get it as your, therefore we can get x of n into x of n plus 2 into x of n minus 1 plus 1 into x of n minus 2. Y of n means y of n multiplied with z inverse y of n minus 1. Multiplied with 0.75, we can get 0.75 into y of n minus 1 minus of y of n minus 2 into minus of 0.125 into y of n minus 2. This is the direct form 1 structure. Similarly, for direct form 2, x of n multiplied with your 1, we can get it as your output. Multiplied with z inverse, we can get 0.75 into x of n minus 1 plus minus of 0.125 into x of n minus 2 into x of n, right? Therefore, y of n means y of n multiplied with, therefore y of n plus again multiplied with z inverse y of n minus 1, 2 into y of n minus 1 plus 1 into y of n minus 2. This is the direct form 2 structure. In direct form 2 structure, we can take z inverse as common. In direct form 2 realization, h of z, y of z divided by x of z is equal to y of z divided by w of z into w of z divided by x of z. Next one, cascade form. H of z is equal to 1 plus 2 z inverse plus z power minus 2, 1 minus 0.75 into z inverse plus 0.125 into z power minus 2. Now we can get 1 plus z inverse into 1 plus z inverse, 1 minus 0.75 into z inverse into 1 minus 0.25 into z inverse. Parallel form, h of z is equal to 1 plus 2 z inverse plus z power minus 2 divided by 1 minus 0.75 into z inverse plus 0.125 into z power minus 2. Therefore, 8 plus minus 7 plus 8 inverse divided by 1 minus 0.75 into z inverse plus 0.125 into z power minus 2. Therefore, 8 we can get it as a constant value plus 18 divided by 1 minus 0.5 into z inverse minus 25 divided by 1 minus 0.25 into z inverse. We can get, taking the partial fraction term, we can get the answer like this. This is the cascade form. Cascade form means we can get it as a x of n multiplied with z inverse multiplied with 0.25. Therefore, 0.25 into x of n minus 1 plus which is equal to plus x of n is equal to, we can get the term. Next one, y of n means y of n multiplied with, we can, all the values can be combined in terms of cascade form, in terms of series. Therefore, which is equal to y of n into multiplied with z inverse y of n minus 1 into 0.5. Therefore, 0.5 into y of n minus 1 plus y of n. This is nothing but your cascade form. Next one, parallel form, x of n multiplied with constant value 8. We can get it as a value. Second value is 18. Therefore, which is equal to x2 of n multiplied with z inverse, again multiplied with 0.5. Therefore, 0.5 into x of n minus 1. Constant value multiplied with your 18. Next value, we can x of n multiplied with z inverse x of n minus 1 into 0.25. Constant value minus 25. By, in terms of parallel, we can combining all these terms, we can produce the output as y of n. This is the parallel form structure. Define block diagram. Block diagrams are represented in terms of discrete time systems, are called as block diagram representation. Mention the structures to represent block diagram: direct form 1, direct form 2, cascade form and parallel form. The system transfer function of linear time invariant dt system is h of z is equal to y of z divided by x of z. In terms of direct form 2, y of z divided by x of z is equal to y of z divided by w of z into w of z divided by x of z. List the summary of elementary blocks to represent discrete time system: adders, constant multiplier, signal multiplier, advancing element, delay element, etc. Identify the difference equation of the given graphical representation: x of n multiplied with 1. Therefore, y of n multiplied with z inverse represents arrow mark, y of n minus 1 multiplied with a. Therefore, which is equal to y of n is equal to a y of n minus 1 into x of n. Y of n minus, therefore y of n multiplied with z inverse y of n minus 1 multiplied with a into y of n minus 1. Therefore, y of n is equal to a into y of n minus 1 plus x of n. Thank you.